welcome to Mentor Availability by Module. That was a project by me and others. So we're going to start by kind of talking about the scope of the project, more the needs of this project, why do we do this project. One important disclaimer before I start this presentation is that I've never practiced it before. So it's a little bit, we'll see how rough around the edges it is. But anyway, back to stakeholder needs. The biggest need is that we wanted to increase the flexibility of mentor availability. Other derivative needs of that were kind of like we want to search for mentors by what they teach rather than what the course kind of prescribes of them. We want to keep the experience of looking for mentors, both for students and for admins, relatively consistent. Don't have to learn a new system. Just see if we can kind of swap out searching by module, this smaller, more atomic entity than courses or programs, and then keep the experience basically the same. So before we get into how we change that, let's ask, how did this work before? So cool guy McMentor Pants teaches a course, for example, software developer track. But the software developer track kind of has these discrete subject areas within it, like programming fundamentals, front-end foundations, back-end foundations, specialization, which is like the project section, and software engineering principles. But if we wanted this guy to teach everything, or if we wanted this guy to teach anything in STT, he basically had to be qualified for all these things, or we wouldn't, we might be able to switch him at some point in the middle, but there is no easy way to know when that would be the right time, or basically no way to kind of filter down, like maybe cool guy McMentor Pants is better at front end, and he doesn't really want to teach back end, but he kind of knows back end, maybe it isn't good for the student or whatever. We don't know this. Basically there's this big glob that they have to know, or that we're saying they know in order for them to teach anything. Basically, mentors could only teach programs. So, for example, if a mentor wanted to teach, like I was saying earlier, if they wanted to teach any STT or WDT at all, they had to know JavaScript, HTML, CSS, Angular, Ruby, Rails, and they needed to know them all well so that the student has a good experience, which create these problems. It's a lot harder to hire mentors who teach all these subjects. It forces existing mentors who want to teach any of our flagship programs to learn material outside of their expertise maybe. So maybe we have some front-end mentors who want to teach WDT because we have a lot of students who are coming into WDT, but they don't really know backend that well, and so they have to learn backend and get trained by another mentor, which means there's a slow feedback loop for getting those mentors up to speed, and it kind of creates this problem of unnecessary hiring and training overhead, and also makes it harder to get more mentors available in the things that they're good at. So how do we want this to work? This is the old system. What do we want the new system to be? Let's say cool guy McMentor Pants doesn't really teach back-end foundations or software engineering principles, but he does teach specialization, programming fundamentals, and front-end foundations. We want to be able to have that granularity of what they can teach. We want to be able to say, this mentor knows these things. Is there a way that we can find and group mentors who know smaller subject areas within a course? We don't care about what the course is or what the program is. We just want to know what subject matters that they know, and can we characterize their kind of teachability by those subject matters rather than what programs do we have at Bloc. The code. So this is a little bit, unfortunately, it's a very complicated system, so making it very readable for a Google presentation was a little bit difficult, so I'll try and walk people through it. You can ask me questions and need clarifications. Before we kind of had this weird looping flow where if you're searching on the admin side, you go through this filtered mental profiles class, which filtered by operating system and start date, which went through the mentor profile class, which was sort of like our model for mentor attributes. It was also kind of like originally designed to be sort of a presentation class that also handled, like, if you look at a mentor's profile, what are, you know, what's their description, or like what's their backstory, what courses do they teach. It was like kind of a catch-all class, and the old code made that very evident. It was responsible for retrieving mentors, so just querying them in general, filtering those mentors, checking if they were available, calling into other classes to organize those mentors, and then sorting the mentors after they were organized, which basically meant ranked by this set of needs that we kind of determined through how close they were to their minimum requirements. So for full-time mentors, you need to have 15 appointments per week. If you're a part-time mentor, you need to have 5 mentor appointments per week. So we kind of ranked them by how close they were to those goals, if they were close at all, if they were above it. And so a lot of everything basically went through here. We had a situation where we were retrieving mentors using a querying interface in the mentor profile, which then went through this fetching available mentors class, which essentially just invoked methods in the mentor profile class. It didn't actually do that much, other than it was kind of narrowing the scope of mentors by their course or course subject. But then we had this other class that was filtering as well by start date and operating system. So we had kind of like similar responsibilities spread out against 2 different classes. And then on top of that, we were checking for availability in mentor profiles. And so it kind of wasn't clear, like we have all these different places where we're doing filtering or finding availability, and it wasn't really clear where we could even look to kind of solve this particular problem. It also had an issue where it was kind of complicated to follow where the data was going. So like it would basically, fetching available mentors would look to mentor profiles for available profiles, but then filtered mentor profiles would also look to mentor profiles. And it wasn't like, you know, it didn't have like a consistent linear progression where the data was being kind of like narrowed down or manipulated in a way that you could kind of predict, because it was being invoked in a lot of different places. Any questions? I was talking a lot there.
What's the bottom half?
The bottom half was actually ended up being not relevant to what the problem we were solving. This is how we organize mentors by ranking, which is what I was talking about earlier. When I was first learning the system, I thought that it would be important, we might have to modify this, but it turns out that we actually did a decent job of making mentor rankings, like ranking what they should be, how, whether we should choose a mentor to work with a student based on whether they are meeting their minimum or are below their maximum. And that actually doesn't care a lot about the rest of the system. It's not intertwined with a lot about with the rest of the system. It's just concerned with finding a group of mentors and ranking them. So it ended up that we didn't need to know anything about this or change much about this in order to kind of solve the problem that this project was doing. So the problems with the old code. This isn't technically actually a problem, but it is usually a sign that there may be some, it may not be up to the needs of the current code base. It was written a lot of it was written in 2013. Many, as I was saying earlier, many of the responsibilities were tied up in a single class, this mentor profile class. I know we are trying to get in the habit of like keeping models. We have a couple of really fat models in our code base. We're trying to make them a little bit slimmer by just making sure that models are used for querying or for like very strict data responsibilities. And a lot of the business processes of finding availability, of filtering, these all were tied up in this mentor profile class, which made it really bloated and made it very difficult to read. As I mentioned earlier as well, there's an unclear flow of responsibilities. It wasn't very clear, like, what is this class doing? What is this class doing? Should this class be doing something before this class? Should the class be doing something after this class? There was a surprising amount of redundant operations. So we had mentors being ranked multiple times. We had querying available mentors multiple times in different classes. Basically, there was a point where, you know, we weren't just working with the same set of data, sometimes we were duplicating the data that we were querying. And as a result of having these kind of monolithic interfaces, we had very complicated tests, which usually tests can act as a form of documentation or give you some idea of how things are supposed to work, and it was not very clear from looking at the test what was going on here. So already you can tell slightly simpler diagram. We basically just wanted to have this very simple progression of the data where we were querying, using mentor profile, we would query to get all the mentors who were active. Once we knew if they were active, they would go through the available mentor finder class, which basically just says, are these mentors available? Has some operations for finding out if they're available, which means like looking at their capacity, looking at their free slots, which I'll go into a little bit later. And then once we know they're available, we hand them off to this filtering available mentors class, which does kind of the responsibilities that fetching available mentors and filtered mentor profiles did before, which was like filtering by operating system, filtering by start date, and filtering by the subject matter. In the old case, it was course and course subject, and in this case, it's program modules or modules. The pain points that this approach solved, clear flow of data and operations performed on it. So we know kind of like where's the data starting, and we're trying to shrink the pool of data as we go further and further up. So we start with all the mentors, and we're shrinking the pool so it's available mentors, and we're shrinking the pool again so it's available mentors that matches certain criteria, whether it be start date, course date, program module, whatever. Code grouped more by responsibility. Means that hopefully the naming of the classes and the operation that those classes perform is a little more intuitive because it's very clear what these classes are supposed to be doing. The classes are also smaller, which means they're more easily tested. And also we can cut down a lot of the bloat of that complicated model that we had in the mentor profile class. Other tasks, this is kind of like a lot of what I was talking about earlier was dealing with like how do we handle the data once we get it. There's also additional data that needed to be created. So we created these two new modules, program modules and mentor program modules, which sort of behave in the same way as courses did in the old availability. Basically, program module is the subject entity itself. It is front-end foundations for the WDT course. It is the front-end roadmap in SET and FST. It is programming fundamentals. And then the mentor program modules was basically this table that was only for kind of relating these program modules to mentors. So it belonged to mentor data and to program modules. So it was easy to kind of like figure out what a mentor taught. So we're gonna get a little personal.
Just to clarify.
Yes.
Could you go back to the slide?
Absolutely.
Teaser. The mentor program modules.
Yes.
Are a mentor join table, right?
No. It's you can pull up the code if you want, but it's basically mentor program modules belong to program modules and they belong to mentor data. And then on the user table we have has many mentor program modules through mentor data and has many program modules through mentor program modules.
Okay.
So this, I gotta say, this is kind of like the end of the sort of like hard technical stuff. It's just like how the problems were solved. If you guys want to have any questions about kind of like any more of the problems involved, then I'd be happy to answer them. Yes, Megan.
Why couldn't you just call the model module?
Yes. Well, Ruby has a restricted keyword, and restrict an already existing functionality called a module. And
Right.
And if you try to name something a module, you will get a lot of errors when trying to create a model with that name. And so we had to give it some kind of prefix that we thought made sense. Program module, we kind of like kicked a couple things around. Program module ended up being the kind of like winner of most illustrative of what it was. But I know that kind of like when we're talking about this entity to non-technical people, we generally refer to it as modules because it's still kind of how we think of it. It's basically a more granular version of the course material. Any other questions?
Did you find a speed, was it faster to query once you simplified the different pieces that were involved from the before to the after? Was there a speed up in load time?
Sort of. There was a slight increase, but I kind of feel like that I didn't really profile to see if it was because we weren't doing as many redundant operations, or if it was because of the classes themselves. I just didn't record the query time and the creation of the new kind of like interface for retrieving available mentors and filtering available mentors was not concurrent with the old interface. So like we replaced it, right? And so I didn't really have like a good forum for side-by-side comparison, I guess. Both of them could be, they both could be faster because there's a lot of Ruby involved. It's not like SQL, there's a lot of filtering with Ruby. That also is an opportunity for how we could speed up in the future, is like looking for where maybe we can do some of this sorting or whatever in SQL to make it a little bit faster. There's definitely places where we could probably speed it up, but I can say that the primary goal when I was writing it was to make it more understandable and readable, and performance was a slightly secondary concern. Because it was already so opaque to begin with that I figured it was good for me and good for anybody else reading in the future.
Cool, thanks.
So, let's get personal. Let's talk about lessons. Did you?
No, that's okay.
Are you sure?
There it is.
So, how did I approach this problem from like a problem-solving perspective, kind of agnostic to what I was working on? I read a lot of code. Surprise, there was a lot of code here. I had to read a lot of it. I had not dealt with the system at all before working on the project, and so it meant getting up to speed with a lot of things and kind of like just grokking how did it work. One of the things that helped with understanding was what I call follow the data, which is basically where you put a binding in every single part that's called in the system, and you're just like, what is the data now? Like what? Okay, it's in this class now. What does it look like? Okay, it's not ranked, but it is all the available mentors. Okay, next part. Okay, now we're into the part where it is ranked, and it's actually not mentor profile models, it's just these hashes of the mentor profile ID and the ranking or whatever. Like it was super helpful to put a binding .pry in a bunch of different places, just hit continue every single time, and kind of like print out where the data was. Also, it made it easy to kind of the reason why I did bindings instead of like just like a put statement or a Rails logger statement is because I could manipulate the data, I could preempt the next step and see like much more easily, like compare side by side. Here's how it was with this step, and here's how it was with this step. I could call some of the like private methods that were in the classes that manipulated the data in a certain way, or supplying values in a certain way. And so that made it a little bit easy to kind of understand like what is the journey that the data is taking through all these different classes and query methods and whatever. I'm a visual person. I really thought diagramming was super helpful for this. I know that there is, what is it, UML? Is that what's the name of the model diagrams? Is it UML? Okay, I know there are like standard ways of diagramming this. I just used OmniGraffle, which was good enough for me. And kind of I was concerned with like how did everything work together, nailing down the specific methods, thinking about is this method actually a class, is this method doing operations that should be private methods in another class. It made it easier for me to visualize what is happening right now and how do I want to change the system, and it also, as we saw earlier, makes it very stark when you notice like how much complexity is being reduced. And you don't want to like try and internalize thousands or hundreds of lines of code to kind of like understand how that complexity has been pared down. Another thing that was important is I created the kind of necessary data for the solution, and then built up the functionality in a piecemeal way. And what I mean by that is like we needed these new models, program modules and mentor program modules. So I did the migrations to create that data, and then I was creating sample data, and then basically was like calling certain methods and like mapping out like solutions in my head and like doing really small operations that I knew would eventually lead up to certain classes or certain kind of public interfaces for what I would be eventually putting into formalized code. Again, that was like in Rails console. So I was kind of like messing around with the data first to kind of get to the point where I was like, okay, this is the most understandable way to do this. And this is how I'm going to put all these parts together to make the finished product. What were some of the roadblocks and difficulties that I experienced? The biggest, I thought I was on track for the first maybe half of this project, and the biggest roadblock that I hit that ended up delaying me by multiple days at a time and ended up being very difficult to predict was tests. So looking at old tests, writing new tests based on old behavior, knowing what behavior is wrong behavior through the tests, dealing with factories that have assumptions about coupled behavior, all that was really difficult. And you get to the point where you maybe you have a factory that's like, okay, well every time this factory is created, and a good example would be like mentored data, which is like an important model for dealing with this, obviously, since we have program modules and mentor program modules, or mentor program modules associated with mentor data. That assumed that every single mentor data entity needed to deal with mentored courses, which is not the case, right? Like we now know that's not what we wanted, but the base factory called mentor data had an assumption about our behavior and was not actually a base factory. So I had to start weighing the costs of, well, do I want to replace everything in the testing code base? This factory is referenced in many places. Do I want to replace everything and then have to deal with running all those tests, making sure that mentally the overhead is there? What happens when we haven't transitioned away from the old models? If I replace that stuff, replace those factories in the old tests, what if it breaks new functionality? And I don't know because I haven't updated the legacy code yet. It was just a ton of overhead, and it made me think about, it made me ponder decisions much more heavily than I think I would have otherwise, and it was completely unexpected. Not completely, but it was like unexpected how long it would take to kind of make those decisions and weigh, okay, well I can have like a factory with like a not ideal name that has like maybe extra descriptors, and just use that as my base factory and go back and refactor it later. But I kind of had to know what the extent of the legacy code was before I could do that. I made a lot of assumptions about what details, not a lot, but some assumptions about what details of the system I didn't need to understand. I thought that I didn't need to know as much about some related systems, in this case capacity and free slots. Capacity being what the mentor sets as the number of students they will accept, and free slots being the delta between that capacity and the number of occupied slots that they have in their schedule. I didn't totally jump into that when I was first learning about the system, and that ended up being something that I had to know about, and so I had to go back and kind of learn it after the fact, and I made an assumption early on that I didn't that I didn't need to do that as extensively as I ended up doing. Time estimation, you think you can do it in a certain amount of time, and then it's midnight on Wednesday night, and you're like, this is supposed to be done in 2 days, and suddenly you're not going to get it done in the time you think you can. And that was kind of a bummer because we did want to hit a certain deadline, but I have some ideas in the next slide to kind of make that better in the future and maybe relieve some of that, the stress and the kind of like hunkering down that I did to try and deal with that. Yeah.
What's the biggest takeaway that you got from this project when you approach writing new tests? And what's the biggest takeaway that you got from this project when you approach refactoring and dealing with existing tests?
When writing new tests, I mean, I will say, it was definitely frustrating to deal with the old tests, but it really taught me a lot about what works and what doesn't, and how to move quickly through writing new tests and kind of dealing with old ones. Definitely, I mean, the number one thing is just like when you create a factory, make it as bare bones as possible. We've talked about this ad nauseum, but just like the factory should make no assumptions about the system. It should be raw data, and then you can have traits that assume things about the system that you can add conditionally if you need it. And I think that was helpful when I was designing the factories that were new for the data in the system. That was something that informed me because as I was looking at old tests, I was feeling the pain, and so when I was writing the new factories and the new tests, I tried to push back against that pain and redesign them to accommodate the problems that I was feeling. In terms of,
Put it another way, it sounds like the preference is to write unit tests that will test very, very limited functionality one at a time, as opposed to testing complex systems.
Totally, yes, absolutely. All these, as I mentioned earlier, all these classes were much smaller than the classes that existed before, and I tried to write them so they assumed as little as possible about the data they were dealing with. So the tests are generally more succinct. The functionality that is assumed the test is generally pretty small, and they're all unit tested. It makes it a lot easier than having to test like the controller action that calls a bunch of these and stuff like that. And so while it may not be as I didn't feel like this was a case where we needed like a feature test or whatever. I felt like the unit testing covered most of the functionality we needed. So yeah, in this case, the small atomic unit test dealing with as little data as possible was very helpful for understanding the system. You had a second question though, that was related to legacy code that I can't remember.
The second question was, what has this experience informed when it comes to rewriting existing tests and refactoring?
I mean, I would say that because there is sort of a time crunch, you kind of have to bargain sometimes. Like you build, like I said, I made what I would consider a poorly named factory that fulfilled the functionality that I needed with traits that were built on top of it. That is basically the blueprint for how I would like to handle these processes in the future. So I don't lose the knowledge of what I'm working towards, and it's working within the new systems. But eventually, I would like to go back and kind of replace the old places where the old factories assumed a lot of knowledge about the system, and break that out into traits, and then just add the factory and the traits rather than the factory that assumed a lot. Ideally, if you have the time and the tentacles of the factories aren't in 15 different classes, it would be nice to refactor everything, but in this particular case, there was a lot of overhead, a lot of knowledge of other systems that I didn't know, and I just didn't have the time. So, I mean, I would say do as much as you can. At very minimum, create the ideal scenario and use it in the new functionality that you're creating, and then when you have a chance, go back and backfill the other other stuff to comply with that new idea that you're working with. What I would do again, so for approaching these big problems, I would follow basically the same procedure for getting to know the code, which is read a diagram, follow the data to understand how the system affects it, plan the architecture. So we did an arc review after I did these first three things to kind of understand the system and diagram them out, which was super informative, helped kind of clarify the thinking that I was having. And it also made it easier for me to communicate putting these things first made it a lot easier for me to communicate the ideas in the arc review that I felt were necessary to get people to be able to actually help me, because the system was not known by everybody involved. And again, I would build the data first and then mess with it in Rails console in order to kind of understand, like, how do I want this to shake out, and then build the systems on top of it. So I actually don't end up starting to write the code for the new classes and the new systems until like very, very far down the line. And there's a lot of like experimentation, a lot of reading and understanding the system beforehand, and also getting lots of feedback if you can. One thing that I didn't mention earlier was I also, to speed up the process, I did not worry about the front end until the front end of the web pages until very far down the line. And almost all the classes that I was testing, I wasn't making requests to controllers from the front end to see how the data was performing. It was all done in Rails console. I kind of like, good old Control R, auto-populate the assignment of variables for the models that I needed, and just use that over and over again so that I could run the necessary code to kind of get a sense. It's a much faster feedback loop than making requests from the pages themselves, and it made it a lot easier to kind of design the system with that in mind. What do I do differently? Communicate with others on my team more. I kind of have a lot of different, just in general, I felt like that was something I needed to do, and what that involved was like pairing. There's definitely some times when I was like, especially with the tests, I think I maybe would have benefited from talking more to other people about, here's what I'm experiencing, this is painful, maybe you know more about the system, you can tell me whether it's worth replacing these, or if it's dangerous to replace these, or whether I should just move on. Because some of it was just like me spending 4 hours playing around with things and deliberating, is this worth replacing now, right? In terms of the timeline and kind of like what I'm struggling with, speak up sooner rather than later. I definitely, I had that, what I mentioned earlier, the being up at midnight and struggling with something, that was actually something that happened. Not that it was, I enjoyed it, I was having a good time, I was learning a lot, and so it wasn't that painful for me, but in terms of being responsible to the people involved with the project, and also letting people know more about the problems that I'm facing, and so they can help me solve those problems. I thought that I needed to be better about speaking up sooner rather than later and saying I'm having problems with X, Y, and Z. What do you think about this? Maybe their answer is I don't know, and then you just go back to doing the same thing. But the point is that I didn't even do that much. I didn't check in with someone to say what do you think? Test the pulse of the situation. Is this something that you would do? How would you handle this? Is this different than what you would do? And then also letting them know hey, I'm running behind. What do I need to do should we compromise on the total plan so that we can get it out sooner? Or is it fine to delay a week? It ended up being okay that it was delayed a week, right? But that may not be the case in every single project. Come up with a more concrete plan if you're not hitting timelines. What I mean by this is before you get to the point where you're behind, usually I would say maybe post arc review. So after you got an understanding of the system, after you kind of know how you want to approach the problem, talk to the stakeholders about what happens if I'm not here by then? What happens if I'm 3 days behind? And you can preempt the kind of after the fact, well, what do I do now that I'm behind, right? So you can just say, I know ahead of time that if it's behind, it's okay, but I should let people know, and they just want to be in the loop. Or maybe it's actually cut out this functionality because it doesn't matter right now, we can ship that iteratively. So communicating that up front, and then also being more proactive and communicating along the line, I think would be better for everybody involved. plan for tests. We talked a lot about tests. This was a big pain point in this particular project. I did not think a ton about I thought about how writing the test for the new classes would be, but I didn't think a whole lot about how reading the test for the old classes would be. When I was learning about the code for the old functionality, I didn't read the test that much. I was like barely looking at them. I was just trying to figure out how the code worked itself, and I didn't realize that, hey, when you ship something new, or I did realize it, but I didn't think about it when I was writing the new code, that hey, when you ship something new, it's probably gonna break like 15 classes or controllers that you didn't think about beforehand, and so when you push that up to a circle, you're gonna get all these errors, and you have to like kind of piecemeal figure out what's wrong with them, and I didn't plan for that when I was estimating time, and I would definitely plan for that next time. And this is kind of the last point, make sure I indulge the details of related systems sooner rather than later. I think that means, like, in the case of the capacity and the free slots that I was talking about earlier, I would learn a little bit more about what those things are up front and not just assume that I don't need to know about it. I'd rather kind of look under the hood a little bit more, even if it's kind of costly up front, and just decide whether I need to know more about the system, and be a little more thorough beforehand so I can estimate more accurately, than wait until afterwards and be like, oh, I made an assumption about the system and now I need to go back and actually learn more about it in order to get my task done. That's it.
I have a question.
Yeah.
So of the hardships that you ran into, were there any that you didn't see like a clear path of how to maybe like shock absorb in the next project, or
Sorry.
the slide that you had where you had the hardships, were
Yep.
there any where there isn't an easy answer? You found like there isn't like an easy fix for the next project?
No. I think that what I would do differently, I think some of these address those hardships, right?
Mm-hmm, yeah.
Planning for tests is a big part of that. In terms of the detail, like I said, the details, you know, like I also addressed that in the other, what I would do differently is like maybe look at adjacent functionality a little more extensively than I would. Look at the tests like I would beforehand, and the time estimation I would address by being more communicative, right?
Mm-hmm.
Like you sometimes based on complication of project and, you know, ability of engineer, there's going to be, especially when someone else is estimating the project for you, there's not going to be a perfect system for estimating, right? But you can mitigate the effects of not that imperfect estimation by being more communicative.
Mm-hmm.
So for the most part, you're the only engineer working on this big project. How did you make sure that like the changes that you're making and everything you're learning about this part of the platform is shared with other engineers, so if a bug comes up, anybody can jump in on it?
Well, so the first introduction was I needed to learn about the system enough that I could talk about it coherently to other people. So like there's like basically a week long of research where I was just learning about what existed. And that way, when we got to the architecture review, I could explain what I was going to do or what I thought we should do in a like coherent and understood manner, I guess. So the arc view is kind of like the first checkpoint. I did talk with Megan a decent amount, and you know, Megan in general is pretty good at reading stuff that she doesn't understand, and so like you know, she was very involved in the review process. I think, you know, it kind of depends on what the bandwidth of the team is, right? If there are other priorities, then maybe I would have like been more proactive about being like, hey, let's just do a 20-minute check-in with here's where I'm at, or like send out a more formal update. I did end up sending out a couple emails that were more towards like non-technical stakeholders about what was happening. In terms of keeping people involved, you know, there's always code review, which isn't a necessarily proactive or perfect mechanism for getting people involved. I try to be thorough with my test plans and my descriptions of what was happening, lots of screenshots, and kind of explain the system in like a piecemeal fashion. So like putting up diffs that were smaller so that they could be more understood, I guess. But it's hard. Like the reality is it's just hard, especially when you have limited bandwidth to kind of like weigh how do I communicate what I'm working on in a way that isn't disruptive to the other people on the team when we all have to be kind of running. And so I would be interested to, when people interact with this code in the future, I know Dave has already had to, for reporting, kind of look at how does the system work, hear what is not well understood. Ideally, in the perfect world, your tests and your code speak for themselves, right? That you just look at it and you're like, wow, this beautiful system, man. Everything is clear. It's not really how it works most of the time. But ideally, you get to the point where you write clear code and it's organized in a way that you understand what each step of the process is doing. But you can prime people by having those architecture discussions in the beginning, making sure they're involved in code reviews, and being as descriptive as possible when you're putting up the diffs so that they don't have to assume a lot about the system. And I actually got that feedback when I was working on one of the migrations. I called it a very impromptu kind of like in-person review on how to backfill all the program module data for mentors. And I think Ariel couldn't make it, I can't remember, but Dave and Megan were both like, I don't understand what's happening in this. you need to be more clear about this, and that was very helpful feedback, getting that kind of reality check of just like, it makes sense to me because I've been in the mud for 2.5 weeks, but it doesn't necessarily make sense to the other people. And so, get the feedback while you can. Maybe not, don't be super pushy to bring people in when they might not be necessary, but offer to explain things in person if you can.
I have another question.
Mm-hmm.
Did anything get scoped out of the project, and is there any follow-up to addressing?
Yeah, some of the deletion of some of the code that I would have liked to have deleted is still out there. I'm like
Deletion of old code?
Of old code, yeah. I'm 60-70% sure that some of it can just be taken away, but I didn't want to increase the stress of a resource-constrained engineering team by just ripping it out and letting the roll bars tell us when we're wrong, So at some point, my plan is to, when I have, it was going to be some this week, unfortunately it didn't end up being that way, is to kind of like, as much as I can, try and get at least one part of that code deletion done, per week. So that I can iteratively get rid of it. It just may not be all in the kind of fell swoop that I wanted.
Is that at least documented as fabricator tasks?
No, it's not. But it is documented in my notes. So I do know, I have it all written down what needs to be deleted and what it touches. I even have a nice little shareable GitHub gist that I sent to Ariel.
On the day that GitHub was down.
Yes. That has the general areas, and then I grabbed for dimensions in the code base. It's pretty straightforward. It's very clear what needs to be done, just as in a fabricator test. And I guess I could make those. Probably should.
Wish I could snap my fingers and that whole paragraph is just moved into a fab ticket.
But yeah, I was thinking about that, and I did want to get it done. I just didn't have the time to do the kind of checks and balances of when I delete this, what are the impacts? Are there impacts? Maybe there's not, but it's in 30 places, so I'm not going to roll the dice.
Cool, thank you.
All right.
Cool.
Thanks, Joe.
Thanks, Joe.
That was awesome. Wah, wah, wah.
Blah, blah, blah.
Wah, wah, wah.